Hello everyone, and welcome to today's webinar. Thanks for joining us. My name is Marcelo Belenazzo, and I'm part of the AWS marketing team here in Seattle. I'm very pleased to host this webinar today, where you get to hear from AWS and Protera Technologies. Protera is an AWS Advanced Consulting Partner and SAP Cloud Certified Partner, and they will share with you their experience building and maintaining disaster recovery environments for SAP solutions in the AWS cloud. I'd like to start with some housekeeping items. And basically, our webinar is going to be about 1 hour maximum. All lines are mute. And you have time for Q&A at the end of the webinar. During the webinar, you can submit your questions by using the Q&A dialog box in your browser. This webinar is being recorded, and you are going to receive a link for the recording after the session. You can always visit the AWS channels on YouTube and the slide share for webinar replays and slide decks. Our agenda for today's session starts with Stephen Jones, Senior SAP Architect Solutions at AWS. Stephen will give you an overview of the AWS platform with emphasis on how to effectively run SAP solutions on AWS. Next up is Patrick Osterhaus, President at Protera Technologies. Patrick will detail the steps required to build a disaster recovery environment for SAP on the AWS cloud. Patrick will also share some lessons learned from a recent implementation at Viskase, a global manufacturing company. Without further ado, I'd like to introduce Stephen Jones. Stephen, the floor is yours.
Thank you, Marcelo, for the introduction, and welcome, folks, to the webinar today. First off, I'd like to spend a little time setting context for the discussion today. Now, the reason you're on the call today is likely due to the fact that you've been asked to research opportunities to either streamline existing operations for your critical business applications, including SAP, or research possibilities for protecting these key applications in the event of a disaster. Now, managing all the infrastructure elements that go underneath a critical business or enterprise application like SAP comes with a lot of complexity. There's servers, storage, data center space, power, networking, and a myriad of other infrastructure components that require a significant amount of time and investment to manage. So it's no surprise that most organizations spend a large portion of their IT budgets just keeping the lights on. In fact, Gartner here estimates that the average IT department spends 80% of its time and resources just maintaining existing systems. That's also a scary fact that many companies have very little invested in DR capabilities because of the complexity and the significant costs involved with implementing separate data centers. So we at AWS really believe that cloud computing is a better way to run your business. The cloud helps companies of all sizes become more agile. Instead of running your applications yourself, you can run them on the cloud where IT infrastructure is offered as a service like a utility. With the cloud, your company saves money. There are no upfront capital expenses, as you don't have to buy hardware for your projects. The massive scale and fast pace of innovation of the cloud drives the cost down for you. And then in the cloud, you pay only for what you use, similar to what you need to do with electricity in your homes. So not only can the AWS platform rapidly speed up the time it takes to provision new environments like SAP, because you don't have to wait for servers to arrive, the actual elastic nature of the AWS platform makes it easy to scale up and down as needed. So at the end of the day, you have more resources, both people and money, left for innovation, which allows you to focus on projects that can really impact your businesses, like building and deploying more critical business applications. So why Amazon Web Services? Well, technology innovation has always been a key component to Amazon.com. It's really driven the growth of our company. And as we've expanded our product offerings for our retail company, the company has also expanded into other customer segments. And after a decade of building and running highly scalable web applications, which you have come to know as Amazon.com, we realized that we had developed a core competency in operating technology infrastructure and data centers on just a massive scale. And so what we did is we embarked on a much broader initiative to deliver this capability to our customer in a platform of services that you can use to operate your own key businesses and your applications. Let's delve a little bit closer into some of the components that make up the AWS platform. At the bottom of the slide, you'll see a level of infrastructure components that make up the offering in a virtualized manner. And we'll talk about specifically what regions and availability zones are in just a minute. Immediately above that are the four major building blocks that most people think of when they hear AWS or Amazon Web Services. And those are the actual compute, storage, and relational database services. And then within the next several layers, you'll see various value-add services which are available in a piecemeal type fashion. Now, of course, you can use just one of the services or a combination of them. But the real point of this particular slide is up at the top sits your application. So in this case, SAP, you're able to choose exactly what makes sense for you and your business and nothing more. Choice is key. We recognize that choice is key for our customers. And then again, you only pay for what you use. You don't have to consume a whole bunch of different things that you don't need. So Amazon Web Services is steadily expanding its global infrastructure to help our customers achieve lower latency and higher throughput. We've got 4 regions in the U.S., including what we call GovCloud, which is a region designed to allow U.S. government agencies and contractors to move sensitive workloads into the cloud by addressing specific regulatory or compliance requirements. And we also have a region in Europe, 2 in Asia Pacific, and 1 more in South America. And then I've also denoted here edge locations, which are locations where our CDN service called CloudFront and our DNS service Route 53 are available, and even more locations to help deliver lower latency experiences for our customers. And of course, as our customers continue to grow your businesses, we'll continue to provide infrastructure that meets your global requirements. Let's delve a little bit more deeper into this notion of region and availability zones. So you can think of regions essentially as separate clouds. Now there's total isolation between regions. Even the control planes, what we call the control plane, is not shared. And there are technical reasons for this, such as latency challenges if we attempted to synchronize everything in, say, Singapore to US East. But the real reason is compliance. Now you are assured that when you put data into a specific region, it's going to stay there unless you yourself move it. And that's a promise because it's important for regulatory reasons. Now the only exception to this is if you're using CloudFront or Route 53, which in case these services are designed to distribute files and records to edge points around the globe. So only the data that you actually put into those services will leave the region. So then within a region, we have this concept of what we call availability zones. And people commonly use the term availability zone to refer to separate data centers, but sometimes availability zones can be even multiple data centers. And within a region, these data centers are connected by a very high-speed fiber network. The thing to remember with availability zones is that there's fault isolation involved. AZs are in the same general metro area for latency reasons. However, they're far enough apart that there's a share as little as possible principle. That's insofar as practical. Each AZ has separate power utilities, separate distribution trunks, network connections. They're on different floodplanes, and so forth. Now, the amount of separation varies according to geography, but you get the idea that now you can take advantage of locations across the globe and even separate data centers today if you wanted, without having to spend a lot of money or time trying to build out all the infrastructure components in your own data center. So it's actually quite exciting. Now when it comes to security, we take security very seriously. I won't spend a lot of time on this slide because we have complete webinars devoted to this topic. But we have gone to great lengths to provide a secure and stable platform where you can feel comfortable operating your key business critical applications like SAP. Specific details for many of the certifications I've listed here can be found on our website. The website is aws.amazon.com/security. Many companies who actually run their applications on us find that they can leverage these certifications for audit compliance. So if you too also look to run your applications on AWS, even for DR, this may be a great option for you as well. Let's talk a little bit about the 3 main building blocks typically used in SAP environments within Amazon Web Services. First, there's EC2. Basically, this is virtual computers, or what we call instances, with a big twist. With EC2, you can obtain and boot new server instances in minutes. You have your choice of Linux or Windows, and you're able to quickly scale capacity up or down in minutes. And that's both with the individual instance sizes, so the amount of memory or CPU available to a particular instance. You can change that on the fly, and you can also add more instances to, say, an SAP environment or web application. So the ability, this notion of being able to scale to fit real-time demand is something that's unique to the cloud. And now with the EBS, or Elastic Block Store, this is a block-level storage for use with the Amazon EC2 instances. The EBS volumes are off-instance storage, similar to what you find in an on-premise world, and this storage persists independently of the life of a particular instance. EBS storage provides highly available, highly reliable storage volumes with a high degree of performance, especially with one of our recent offerings, which is called Provisioned IOPS, where you can actually specify up to 1,000 IOPS per volume. So that's pretty exciting as well. Typical uses in an SAP environment would be for the SAP software, the database software, database log files, and maybe intermediate backups until you might use S3. And S3, which is also listed here, is a simple object file-based storage service, and we provide a simple web service interface that can be used to store and retrieve any amount of data for any amount of time anywhere from the web. And it's very highly durable. It's got 11 nines of durability. Now, this particular storage can't be mounted directly to EC2 instances, so then it's used primarily for object-based storage. In an SAP environment, people typically use it for backup purposes. For instance, there is an Oracle utility called RMAN, which you can use with an SAP environment to back up directly into S3 and then recover those backups. Let's talk a little bit about some of the network options. We have an enterprise security model that operates similar to the way you'd expect an enterprise network to behave. Let's wait here for the slide to advance. There we go. We have this notion of the Amazon Virtual Private Cloud. And with this, you're able to basically electronically isolate all of your servers into a private virtual network with multiple subnets. You can even choose an option to ensure that no other virtual machines, if you want, are able to run on the same underlying physical hardware. Now, Amazon VPC enables you to provision, again, a private, isolated section of the AWS cloud where you can launch these instances that we talked about in a virtual private network that you get to define. You get to control the IP address ranges and CIDR blocks, subnets, network and firewall rules, and whether there's even internet access into or out of this particular private cloud. In addition, Amazon VPC provides you the ability to create a VPN or a private connection, say to extend your data center from your data center into the virtual private cloud, and then your data center, this VPC just becomes an extension of your data center. And Patrick will show you an example of this a little bit later with what they did with Viskase. So what are people doing with SAP on AWS? We'll talk a little bit about some of the use cases that we're seeing. There's a lot of use. People are seeing a lot of value in using SAP for very rapid deployments of demo, training, trial systems for testing, say, enhancement packs or the new support pack. People are quickly seeing the value in being able to spin up projects rapidly. I alluded to earlier that you don't have to worry about waiting for hardware to arrive into your data center before you start a particular project. There's this notion now where we work with a lot of partners such as Protera to offer like project accelerators where SAP systems are pre-installed, pre-configured to a certain point, and then those can be deployed directly onto an instance. And then literally within less than 10 minutes you can have a base SAP system up and running, with which you can test with. The actual topic of the conversation today is disaster recovery. We're seeing a lot of people use AWS for disaster recovery for enterprise applications and SAP in particular. And then one you may not have thought about before is, typically in a company there will be these systems that lay around that need to be kept around for regulatory compliance reasons. There's data that's in there that has to be kept for, in the U.S. I think it's 7 years or something of that nature. And these systems are typically running on old or aging hardware with expensive software or hardware maintenance. And so we're seeing companies, they just love to leverage AWS for these systems, as they can be shut down most of the time and then just spun up when they're needed. So the actual cost for running these systems is much less on AWS. There are single solutions. There are a number of offerings on our marketplace for Afaria and Business Objects, and all of the SAP RDS solutions are available through SAP on AWS as well. And then we have companies hosting their complete SAP landscapes on AWS as well. We'll give you a couple examples of what some companies have done with relation to SAP. I've listed a few here. We had a global cosmetics company who migrated their training and prototyping landscapes. They were Unix-based. It was quite a large landscape, 35 systems here, and you see about 20 terabytes of storage. And their estimated savings was approximately $18,000 per month. It was about 36% reduction in cost compared to traditional Unix, their traditional physical Unix infrastructure. Recently had another company who was struggling with meeting the demand, the actual demand for compute capacity due to the seasonal nature of their business. So they decided to leverage AWS for this elasticity that I talked about earlier. They're now able to scale to fit the seasonal demand, and they're quite happy with that. We have a global media company that have migrated their entire SAP non-production landscape. They're running SAP ECC, Business Warehouse, Afaria, and all the other myriad of NetWeaver type systems that you can imagine come with a full SAP landscape on AWS, and looking to do production sometime soon. And then there's SAP themselves. SAP is one of the primary users of AWS for SAP systems. And I wanted to highlight just a couple things that they've been able to do here. They use this a lot for training, and there's an instance here where they were able to basically, I talked about this notion of these images that can be saved of these systems. They're able to launch for a training class recently 130 systems the Friday before, and then they ran these systems for 8 hours a day and shut them down, so they didn't have to pay for them after that. And then at the end of the week, they just turned them off and went about their merry way. So they were quite happy with this, not only from a cost savings perspective, but from the agility that it provides. And then I've put a link here to a website on SAP's website. It's for where you can actually launch your own SUP or HANA development environment in a similar fashion, where these are pre-installed, pre-bundled instance images. We call them Amazon Machine Images. And again, within less than 10 minutes, you can have your own environment up and running, and you can play with this. So what exactly is certified for AWS from an SAP perspective? Well, back in 2011 at Sapphire, we announced support for SAP Rapid Deployment Solutions and Business Objects. And then this year at Sapphire in May, we announced support for the business all-in-one solution, as well as Afaria version 7 or higher. And those are available on either Linux or Windows. So you've got both options there. Bottom line, there's a big potential here to save your company money when it comes to running SAP on AWS. In fact, VMS, a German management consultant staffed by a number of ex-SAP executives, they recently independently published a TCO analysis for SAP environments. And the research showed that running SAP on AWS can result in an actual infrastructure savings cost of up to 69% when compared to on-premises or colo-based hosting. And you can find a copy of the study on our website that I've listed here. And also on our website, we've taken a lot of time to put together white papers, support information, and other best practice and other helpful information that can get you started very quickly. Some of these documents are very technical in how to get started. I think you'll find it very useful. And with that, I'd like to introduce Patrick. Now, one of the things that's very important that we hear time and time again from our customers is that they couldn't have done it without a partner. Partners are key to being successful, especially with SAP installations on AWS. With that, I'd like to turn the time over to Patrick, and we'll discuss the DR concept on AWS.
Thank you, Stephen, and welcome everyone to this portion of the webinar. I wanted to introduce myself. I'm president of Protera Technologies, and we'll do a quick intro here for, let me get to the right slide here, of our company overview. It should be populating here. So Protera has been in business since 1998, and we have been focused this whole time in the SAP universe for IT services. We started off doing SAP consulting, and then over time we started doing work for AMS and managing remote customer systems of SAP for customers, and then we moved into the area of doing hosting, and most recently getting into the cloud area for SAP. We have 3 certifications from SAP. We have in cloud, hosting, and AMS, and we'll go through a little detail here on those services in this slide. So you're all familiar here with this model in one way or another. You're running an on-premise data center where you have your hardware and network all in one location, or you have an outsourced data center, which you may work with a partner with a data center that has all your hardware, networking, and power taken care of. Or you may have a model where you have a data center with virtualization at where you're now taking advantage of some new technology that's been introduced in the last few years for IT to save some cost and help with replication and moving resources from one physical server to another. And lastly, we're here to talk today about the power and the advantages of going to an AWS platform. So in AWS, as Stephen mentioned before about the rapid provisioning and the scaling up and the on-demand nature of the platform, how can we take advantage of that for SAP systems? So in today in particular, I want to talk about how we can apply this technology to DR. So a little bit about the certification, as Stephen mentioned before. We Protera worked hand-in-hand with AWS and SAP for the certification of the products that Stephen mentioned before to run on SAP for AWS. So the requirements here for certification is a bring your own license model. So the customers will still buy the licensing through SAP, and they will apply that then to the AWS infrastructure. The certification covers 2 instance types, and we won't go into the exact details here on the sizing, but as Stephen mentioned, the instances are relating to compute, and that is the RAM and CPU sizes for the instances. So right now there's 2 instances that are approved for productive use, and there's a myriad of other instance types that you can use, and you could use this for non-production. A little bit about SAPs, and we'll go into a lot of detail on this today, but basically it's a metric of how much horsepower your system requires to do its day-to-day operations. And this information can be found as well as the SAP Quick Sizer and the metrics there in the note that's referenced in this slide. So a little more about that certification in AWS. As Stephen mentioned previously, SAP has certified the RDS, the Ready to Deploy solutions, FobJ, All-in-One, and Afaria. So these are products that are certified for SAP, can be run for productive use, and fully supported in the model. And matter of fact, there's instances of all these that are available in the SAP marketplace on AWS. So you can provision an instance from an image and fire it up very quickly with a predefined template for the operating system, database, and the SAP application. So Stephen mentioned some really good examples about, how can you use SAP in different scenarios for AWS. We offering a couple more here, and these are examples that we already have taken advantage of for productive customers that we utilize for SAP. So we have a cloud deployment of production landscapes where we can now take advantage of the on-demand nature of the AWS platform, where we can save CapEx money, and we will only provision that hardware when the application or development team is going to need it. So we've had a company that Stephen referenced in his previous slide where they went live on AWS. They originally slated that they would start blueprinting in March, and they ended up starting it a month later. So instead of having those systems sit there idle and compute, utilizing compute resources, we shut them down, idled them for a month. So the customer saved resource, money for that, as well as, taking advantage of the on-demand nature, where if they could bring up the system for a day and wanted to prototype something, they could do it. So took advantage of the no CapEx and paying as you use, and bringing those systems up as needed. We also have a nice scenario of hybrid. And the hybrid, if you haven't heard of this term before, is a combination of cloud technology with on-premise. So we have combinations of customers running their dev systems and quality systems, as Stephen mentioned, and then they'll have production on-premise. We actually have the converse also running. We have companies that are running their production systems in AWS and their dev and quality on-premise. So this brings up a lot of interesting points on hybrid, and there's a lot of considerations. This was a key point to the SAP certification, in fact, that SAP wanted to ensure all operational functional capability of printing, faxing, transports, all these myriad of issues that a customer is going to have for day-to-day maintenance, that all would work within the hybrid model. And there's a lot of information on this topic. There'll be a forthcoming webinar on this in the future, just talking about all these considerations. And this also gets into a lot of information on the networking, which Stephen mentioned before with VPC and Direct Connect. So very good subject. I think this is a really interesting area for companies to explore, and they can immediately have some cost savings and utilize the innovation of AWS for a sandbox system. They could start out as simple as that. Which brings us up to this next example here with DevLab. DevLab is a marketing term, Protera, we use for the images that we have as a library that we can quickly provision a CRM 7.0 system. So for that fact, if we have a customer that comes to us and asks us, hey, we want to do a prototype for a week on this new version of CRM, we can quickly deploy that and bring it up. So instead of having a 6-month lead time for getting a project underway and getting the infrastructure and then testing it out, we can have it provisioned essentially within hours, and we could do a very quick prototype to see if a function that a customer is looking for would suit them or not. And then lastly, the topic we're here to talk about today is the cloud-based DR solutions. And this is something that I think is one of the areas that we're most excited about for what we've tested in DR, because the inherent capabilities we're going to see in the AWS platform lends itself very well to DR solutions. So with Protera, we migrated many customers over to the cloud for DR, and we're going to show an example today and some of the benefits in these next few slides about what the benefits and how you can apply that to your customer systems. So let's talk a little bit about the typical DR concerns, and these are some, not the end of the list, but we're going to talk about the ones that we typically get from customers. And I'd like to utilize this Q&A session. If there's other questions that aren't on this list, feel free to add it to the Q&A section. We'll make sure we can address it as best we can with the time we have today. But the first ones we have here is the geography of the DR systems. Obviously, you don't want to have a DR system in the same 10-mile radius where your primary location is located. So you want to have it where it's far enough away where if a natural disaster occurs, it's not going to take out both sites. So obviously that's always a consideration that we're going to be looking at with any DR scenario. RPO and RTO, how much time and how much data can we lose? That's always a big concern. The sizing of the DR systems, how big do we want those systems in recovery mode? How big should those systems be? And then whenever we declare a DR or when we want to test DR, how big should those systems be so we can do a proper stress test and a proper functional test with all the interfaces running and connectivity to the peripheral systems? Which lends us to this next subject about connectivity and synchronization. Simply, how is it accomplished? It's a pretty complicated subject. How can we do it? And then the other consideration about testing. How often should they run and what should the test be? And another bullet we'll address here, and I didn't put on the slide, is how do we build the systems? That's another big constraint on time and resources is every time you test the system, you got to sync it up again, and how do you rebuild that? What's the process involved? So we're going to go through all those topics here in more detail. So let's talk about geography foremost. I think, as Stephen mentioned, just the vast choices around the world for AWS presence where you can put your data in a data center for AWS. So we have this concept about the multi-zone, and that multi-zone where we can replicate data within that zone. So you have data centers in a zone that are many miles apart. So not only are you taking advantage of geographic distance from your production system, but you're also taking advantage of redundancy of data in that DR second location. So it's a very unique, very big benefit of the AWS platform where you're getting that protected data in another location. And as you can see in this slide, you got a lot of choices, including, the GovCloud location with the highest security for, government standards. So a lot of choices. It also comes into a pretty complicated and question about regulatory and laws and where customers want to have that data provided. So where is it located? So this is another concern with the many locations in AWS. We can make sure we can provision it in the right location. Another key consideration is the RPO and RTO. So one of the big drivers for this is going to be the technology used for the synchronization. And we have used a myriad of solutions here. I'll list a couple here, examples that we've seen in solutions in the past. Essentially, the model we follow is that we will ask the customer foremost if they have a tool that if they have DR already, if there's a tool that they have used and they prefer to use, that would be our first inclination that we would do that. Otherwise, if they want us to provide the solution in whole, we can do that also. So we have done a lot of native database technology of log shipment and synchronization tools, including tools that we've built for synchronization of file systems and drives and interfaces. And I'll talk a little more about that coming up, but that's the key driver here. What are we going to use for synchronization? So RPO is essentially how much data can we lose in a DR event, and RTO, how long does it take us to get that data, that system back up? So key drivers there. Our standard that we would typically start with and ask the customer if it's acceptable is a 4-hour RPO and a 2-hour RTO. And if you have questions on that, feel free in the Q&A. We can talk in more detail. Just putting them some broad strokes on our standards. So this brings us to the conversation around DR sizing. And really this is a business decision that we have with our customers on how big they want that size. We have it from down to 50% for some customers up to 100% SAPS ratings, where they will want to build the system to the exact size that the production system runs so they could have the full load, full interfaces, everything running as it was in production. So again, it's a conversation we have with the customer and size it appropriately. The AWS platform scales extremely well. The M2 4x large is a pretty large instance that we can use as a database server, and then we can add additional app servers as needed, so it can scale quite large. Stephen mentioned previously about a very important subject here in the connectivity. So there's a lot of choices for connections. There's the direct connect technology. You can also do MPLS circuits, and also you can do the VPC, virtual private cloud or virtual private connection. So the VPC is an inherent function in the AWS console where you can provision your networking. You essentially have virtual switches, virtual firewalls, virtual routers, so you can create the myriad and advanced topology of your network in AWS where you can have VLANs to separate a customer system from a DMZ, which would go out to the internet. All these can be brought to bear in AWS also. So you have a lot of advanced features for networking that you can protect these systems and recreate essentially what you will have in an on-premise solution. You can bring it to bear in AWS. So it's an important topic. That's an area that we get a lot of questions on. And when customers are looking to migrate to the cloud, how can they recreate and comply with all the stringent networking requirements that they have? And the good news is that we can fully satisfy all those requirements. And with the strictest audits, we passed them with AWS. And then lastly, this bullet point here about the third-party tools for synchronization. Again, it's bring your own tool. We can apply it in the AWS model. The big driver would be if it's x86 based. So we're looking at platforms that would be essentially non-proprietary systems. So we're looking at Linux and Windows x86 systems. So as long as those tools run on x86, it can be brought to bear here. Brings us to our important topic here about testing the system. And this is one of the nicest features about DR in AWS is the ability to create a quick test at any moment. And a key part to this is when that system is being built and copied for creating the test system for DR, your recovery DR system is still available the whole time. There's some scenarios for DR where they'll bring up the DR system, and while the time that system is being used for a test, it is breaking that recovery system that's in recovery mode. So at that time, the customer's at risk that if a DR was declared, they're rebuilding the DR system from scratch, and you have that lead time of days to build it. In this scenario that we are talking about here, we are going to have that recovery database up the whole time that the system is, the production system's up. So it's always in synchronization. It's always getting the latest updates from production. And then when there's a point when the customer wants to test the data synchronization is quiesced or paused for a few minutes. And then the copy of production is started. So a snapshot is the term that AWS utilizes for a copy. That copy is started, and once the snapshot is started there and initialized, we can bring that recovery system back online. So the customer is not at risk for more than a couple minutes where that log is not being applied. So key feature there, it's very, very nice where we can build test systems very quickly. So you could have numerous DR tests going on, different systems at different snapshots, and we've had that from customers where it opens up a whole lot of questions now that customers never been able to even entertain, where they can do test every month. They can test, when after they put support packages, or they even did it on a sandbox system, they could build a DR test on that and then test it, before and after the application. And then, with testing, it's very important that we try to do an exhaustive application test of the system. So after the system started, we're going to be firing up the interfaces and third-party products and having those connections, going over those connections that Stephen talked about with VPC or the Direct Connect. These connections would go back to the on-premise systems or the other hosted platforms that it interfaces with, and we test those out. So this is very business specific. Each customer is going to have different tests, but we encourage to come up with the checklist. We do that as a standard for all of our customers, and that's what we'll run with through the test. And typically, we'll keep the system up for at least a week. All right, another big question here is how we actually build that DR system at AWS. So the process that we utilize most of the time is a system build is we will do a copy of that production database. So it can be done in a matter of ways. Typically, it will be with a backup, so we don't have to interrupt the production system. And we will copy that backup onto a NAS device. And that NAS device will then be connected in the primary data center, wherever that's located for the source system. We'll disconnect it from there. We'll ship it overnight to AWS, and then they'll directly connect it into the data center where the instances will run, and we'll utilize the AWS import procedure. And this is an automated procedure that AWS has. You create a ticket. It's very nice. You get tracking numbers. You can see the status as it's importing, and you can see exactly how that data is getting copied over to the S3 storage. And once it's available for S3, or there's an option for EBS also, once that's available, you get an alert, and you can go over there and start your instance up. So it's a procedure where the resources of AWS are taking care of the import for you, and then you'll, once the data is there available in AWS, then you can restore it or import it, however method you use for copying the data off, and you would build up the system from that. That system build is really only going to be required in the initial build, or when there's a very large change done that you want to recreate the DR system in whole. So example might be if you go through a large support package upgrade, or if you do an enhancement package upgrade, or if you do a full version upgrade, those would initiate a new system build. Some customers want to mirror the build of the OS patch. They'll patch the mirror system on the destination, but that might require a new build also if you do an operating system or database upgrade. What's important here is during that system build is when the connectivity from the on-premise systems is established. So we're going to be designing the VLANs, the customer networks that are going to be in AWS, and connecting those back to the on-premise system. So usually these two steps are done in tandem because it'll take a little bit to get the networking team of the on-premise group to establish connectivity and get that running. And these connections stay up static 100% of the time. So it'll be another hub. There'll be another spoke, I should say, off that hub of the company. We just, before I leave that last slide, I should make a point. The last DR we did, I literally, the whole process took a total of 3 days, and that includes the backup in the source system, importing it into AWS and bringing it up. So that's the first time build, a total of 3 days, which you can think and compare it against builds that you all have done for DR before. It probably would be measured in months. So it's the quick provisioning can't be emphasized enough of how fast you can move projects in AWS. So this slide here brought up is another key point, is a question of how do we get a system if we had to move it then out of the DR location back into the on-premise system. And it's just the steps in reverse. So we've prototyped it. It works. We haven't done it yet for a customer. We moved it out of Amazon. Yet in theory and in testing, how this will work is we're going to then copy the system out of AWS. So instead of the import procedure, we're going to use that export procedure, and we're going to build that production system back on the on-premise location, and we're going to do a cutover, much like we did for the build. We'll do for the return. So let's summarize about some of the key advantages we've seen already in the numerous systems we put in DR and AWS is what I mentioned before, the fast deployment. You can literally build these systems in minutes. And another key feature is that copying. So the snapshots where you can build that test system very quickly, have it available. You have numerous test copies. You can leave them out there for as long as you want, and you will not be running additional risk on that recovery system being available. The simplification of the DR testing, again, the numerous test copies and basically the ability to create them as needed, so you can have one, if a test group's still using the old test and still testing something out, you could have another group create a new image. The networking, where we have numerous choices and highly redundant carriers into the AWS cloud, it's probably the best platform to be if there was a natural disaster that would affect a geographic region. It's the most diverse and the most resilient platform available for having DR in another location for protection. And gets into the resiliency with the multi-zones. So we have that area where the data in S3 is replicated within that region of the multi-zone. So multiple data centers will have copies of that same data. And lastly here, which is an important part, is AWS is continually innovating. Within the last 2-3 years we've been using AWS, that the products have come out at an astonishing pace, and it continues to not only become more cost effective, but new products are continually being brought to bear, and that's something that you can utilize here for additional functionality in your solutions. So just circling back on one of our previous slides, the idea is, how can you deploy AWS? How can you hook it up? We've seen all these scenarios where you have another cloud provider connecting to AWS. You have corporate on-premise to AWS, and you also have outsourced data centers to AWS. So all these are all in use, and all some of the options we'll utilize for networking to connect might be different, yet they all work. They've all worked and been tested. Some best practices that we recommend, that industry standards, that the testing is done periodically in AWS. Is an easier thing to accomplish and keep that recovery system running. The interface testing, which will be customer specific, doing that for a good sampling of interfaces at minimum, but definitely good to have the interface testing done and making sure that the synchronization of logs are occurring. Sample of printing is good. I'd add to that even faxing or any other kind of business output to make sure that is working. And then third-party products, we should test those as much as we can. There's some different philosophies from customers how much they should put in DR. We've seen some companies where they will put the bare minimum, like vertex or tax calculation. We have other companies that have replicated their whole suite of tools into AWS. We have this slide here just as a consideration. With any kind of production use computer system, we want to have SLAs, and we can confidently say that our SLAs on AWS are as good as any other platform we've seen. In fact, they're better. Where we are providing an SLA to what we mentioned before about the time and how much data we can lose. We're providing that in the AWS cloud for DR. So this includes the synchronization, the build of the systems, how fast we can provision them. All this is covered within an all-inclusive SLA. So it's, again, we have full confidence in the platform and it being used for productive use. This brings us to our case study. Stephen mentioned before, it's a company by the name of Viskase, and it's a very interesting company. They are a processor of meat where you probably use their products and not known it. They do the sausage and hot dog casing, and they have locations around the world. They're located here in Chicago, the United States. They have locations in Europe, in Asia, and in South America. So they are a very diverse company. They have users from around the world, multiple languages, 24/7 requirements. One of the most interesting things you'll realize about this landscape is you'll see the version of it. It's a 3.1i system. They implemented SAP in 1997, and they've continued. They did a few upgrades early on, and they've kept that system, continually growing. It's a heavily utilized system, and so they came to us about 3 years ago, looking for a solution for DR, and we thought that it would be a really good, solution for AWS. It would fit the requirements very, very well. And so we brought to bear, what some of the requirements and location, all the considerations we talked about in the presentation, and we thought AWS would be a great fit. So what we mentioned before about the testing is something that this case is utilized quite heavily. So we utilize it in the Oracle system in 9.2. There's not much inherent functionality, so we utilize a lot of custom programming that we built for this product. In newer versions of Oracle that we've implemented DR, the tool sets inherent in the platform. So I think this is a really good example that even with older versions of SAP in the database, the AWS DR still is a proven platform that can work. And just to give an idea, it took about 3 weeks to build this out, from including the project planning and the actual rollout from production into AWS where they were testing. And it took about another month of testing and getting it fully realized that, that they were happy with synchronization, and when they did a test, it was coming back with their full expectations for the business. So it's been a very successful implementation, and they've been live with it for quite a while and tested quite routinely. And just to give a picture here, we'll finish with this slide, is a demonstration of their corporate network, the data center where they have their production SAP system, and then the Amazon, the AWS cloud, where we have the replication going over. In this scenario, it's a VPN. So we're utilizing the VPC connection that Stephen mentioned previously. And so this VPN connection is a static network connection that's available 100% of the time, and the synchronization is going over that. If that would fail for some reason, if there's a connection, we have a backup VPN between the other data center to AWS. So we have some redundancy in the connection there if it would fail. So with that, we can open it up to Q&A, and if there's any questions, we can answer those now. So Marcelo, if I could turn it back to you.
Sure. Thank you, Patrick, and thanks to Stephen. Now we're going to take a few questions from the audience. If you haven't done so, please submit your questions now. We'll start with a couple of questions submitted previously. And Patrick, we have a couple of questions related to what you described, the Viskase implementation. One of the questions is related to synchronization or replication. And this particular person is trying to understand who is responsible for the data synchronization and replication, if it's the customer, AWS, Protera.
Good question. So foremost, we have monitoring that's set up on the connectivity. So we're looking at latency, any kind of high ping rates, anything that might jeopardize, the throughput of logs or synchronous connections that are sending data from the production system over to AWS. So for ourselves, we are responsible for monitoring. If we would see an event where we see throughput jeopardized or the connection terminates or breaks, then we will troubleshoot where the issue is, if it's on the VPN or the direct connect, or if it's on the other side of the company. So I'll get a little too deep here, but I'll keep it brief. We actually have monitors set up where we can test both ways. So we can see if we try to ping into the customer network to see if possibly the error or the cause of the problem is on their side, or if it's somewhere else. If it's in the customer side, we'll engage them and work with their team. If it's on our side, then we'll escalate internally and resolve it. So I guess that the short answer is that Protera is responsible for monitoring and escalation as needed. We'll engage the customer if required, and it's something that's 24/7 that because it's a primary requirement for DR to be in sync.
Okay, thank you. There's another question related to actually data encryption. If you use data encryption for SAP data in the AWS cloud.
So far, we haven't had a DR requirement with data encryption. It will be supported, so it is possible. I should mention that the tunnels are encrypted. So a VPN tunnel is secure. It's encrypted itself. So the data over a network is secure. I think the question that the attendee is asking is the data itself encrypted? And so far, we haven't had that requirement from a customer yet. It should be supported from SAP if you have the data encrypted in the database, and we would just have to make sure the method of the data that's being sent and received is being transferred in a secured method, and there's certificates in place that obviously that's a requirement for it to work. So the answer is we haven't done it yet. Yet we technically it is possible. It's something that we could test.
Excellent. We do have a couple of questions here for Stevens. I think the first one is related to RDS, and this customer is trying to understand what the SAP RDS solution on AWS encompasses.
Yeah, so the certification for the RDS solutions provided by SAP encompasses all of the RDS solutions. There aren't any specific restrictions.
And there's a question regarding new SAP solutions like HANA running on AWS.
Yeah, so currently we've worked with SAP to offer a development version of the HANA environment. It's actually a free developer license. I mentioned earlier in the slide deck where you can go to developers.sap.com and just register and quickly provision a HANA development instance. And currently that's the only HANA-based appliance available on AWS.
Mm-hmm. Thank you, Stephen. So Patrick, another question regarding the Viskase case study, and this question is particularly, it's actually related to the network diagram that you showed, and I think the question is really related to the fact that you showed the Protera data center. So the customer is trying to understand that the role that you guys play in the solution, and this is different from the AWS cloud.
Good question. So yes, to answer the last question, so in this diagram, I believe it's still being shared, that Protera data center is a separate data center in a separate geography than the AWS cloud. So in this example, the data center where that is located is in Miami, Florida, and the Amazon Web Services cloud is in Virginia. So quite a distance between them, and within the Virginia multi-zone, that data is replicated then through those 3 or 4 data centers in that multi-zone.
Mm-hmm. Okay, thank you. Another question, I believe, Patrick, but feel free, Stephen, to chime in, is regarding the difference between a snapshot and a full copy for a DR system, and when we use each one of the options.
Okay, I'll start, Stephen. You can add, please. So
Sure.
A snapshot we can utilize that. We would quiesce the log application for DR, and at that point we prefer to stop any kind of services that are running on that server. It's only going to be about a 2-minute event where we just have to wait for that snapshot to finish. If you're familiar with VMware technology, it's similar to that, and their snapshot technology where it's taken an image. Once the image starts, we can actually restart the services on that source system. So that snapshot's done, and once that's finished, then you have the test system that you can use. The second part to that question was, what's the difference between a snapshot and a copy? So one of the inherent features of AWS is you can create images of a system. So, and this goes into some of the slides we had about the features, and you can quickly provision copies of systems. You would take a snapshot of a system and copy it, and you can create what's called an AMI, an Amazon Machine image. That image then can be used to create numerous systems from that copy. So you could do a baseline install of, say, a CRM system. You could create an AMI from that, and then that system will be your baseline for all future CRM installs. So the means you go about doing them is very similar, yet you can apply the copy to create new systems, whereas the snapshot, we would do more in a need where you would create a one-off system and you would bring it up for DR tests. And Stephen, I'll let you add any more if you want to add more context there.
No, that sounds great. I think you mentioned that for at least the full copies, typically you would do that only at the initial time when you're taking a full copy of the production system into AWS, and then from there on you just leverage the log mirroring, or whatever the database mechanism is for getting the changes to the standby database.
Excellent. So I think we have time for one more question, and this question is for Patrick. What operating systems and databases does Protera do disaster recovery for?
So it ties into our slide where we had about tools. Essentially anything that's x86 based is game for us to be able to set up DR. We've had questions, can we do DR for AIX with DB2? Technically it could be possible. It's more of an issue, will SAP support it? And that's the tougher question to answer. So I think we could say to enable DR for AWS, to have that source system on an x86 platform, that would be the requirement.
Excellent. Again, thanks everyone for joining today's webinar. Thanks Stephen, thanks Patrick for your presentation. And we'll send a follow-up email to all attendees with a link to this recorded presentation. And on behalf of Amazon Web Services and our presenters, thank you for joining us today.